Okay, so this is a little practice quiz that I'm giving you guys today. This will help you to review the concepts of linear and volumetric expansion and heating curves. So you're going to have a quiz on this tomorrow. And so with this practice quiz, number one says, what is the change in length, okay, of a 4.02 meter brass rod when it is heated from negative 22 degrees to 114 degrees Celsius? So what we're given here is the mass, and we're given a temperature change, and we're also given alpha. And this is the constant that we're going to use for the linear expansion. So you're going to use this equation, okay? And you're going to fill in all those values to calculate delta L. So take a moment to try this question on your own, and pause the video, and when you're ready, I'll show you the answer in a minute. Okay, so hopefully you've had a chance to give that question a try. Again, you just basically plug everything in. The meters there, that's the LO, that's the original length. And the temperature change is the difference between the final temperature minus the initial. It's 136. And you can use your alpha right here, and so you should get 1 centimeter. I did use sig figs. If you didn't use sig figs, you might get this. And you can show your answer in meters as well. That's totally fine as well. All right, so just so you see you're on the right track there. Let's go to number 2. So question number 2 looks like this. What is the change in temperature experienced when 25.4 liters of gasoline expands to 29.9 liters? And here is the B as well. So if we go back to those original formulas, you're going to have to use here now, this is volumetric expansion, so you're going to use the second one for number 2 there. Plug everything in and see if you can get a volume. So take a moment to try that one. All right, so here's the solution for number 2. Using our volumetric expansion equation, original volume right here, V0, V naught is original volume. Plug in your beta, your constant there, and your temperature. Now I didn't put the units here, so just make sure that your units are lining up. Liters here, and again temperature, and this constant right here is going to be in, what is that? So that the units is just per degree Celsius. So students, this is important to know. The unit for B, this beta is in delta degrees C to the -1. So it really doesn't mean much. What it means is that you multiply this by delta T, right? So that the C cancels out, and then whatever volume you have here, that's the volume change that has to match up with this one. So the units for alpha and for beta are just per degree Celsius. So you should get a temperature change of 186 when you pile that one in. Okay, so here's the last one. This will take maybe a little bit longer to do, but this is a heating curve question. So I want you to sketch the heating curve.
Attention all.
So to sketch the heating curve, well, I'll let you do it, but just a heads up, you're going to, starting temperature down here, and in this case, we're talking about water at negative 11 degrees, so that's going to be ice. So we're going to be heating the ice. It's going to get to water to melt at 0, and then it's going to go all the way up to 33. So this is the sort of graph I'm looking for. You should write down your temperatures here. And that will help you determine, the sections. You're going to have 3 sections here. You're going to have to calculate the energy for each one. And so using the data on the right, go ahead and take a moment to try number 3. Okay, and here should be your work for number 3. As I mentioned, the 3 sections there. The first one is going to be E equals mc delta T, because there's a change in temperature. The graph's going up. And you're going to want to use the C for solid right here. Solid water, okay? That's C for solid. So plug in all of your numbers, and you should get an energy related to the first section of the graph being this right here. Now, section number 2, again, there's no temperature change, so this is This is the change of state. So this is E equals ml. And you use LF, right here, you use LF for this question because it's the latent heat of fusion. So the energy related to this phase change right here should be that right there. And finally, the third section is another E equals mc delta T because the graph is going up, right? It's increasing, so we need a temperature change in there. You use the C for liquid because this is liquid water being heated up. And so you use the same mass, which again should be converted to kilograms because these constants are joules per kilogram per degree Celsius. And you should get a temperature or an energy for section 3 of about 90 or 9,000 here. So you add up all those together, and again, if you use 3 sig figs, which would be in the question, you'd have 3.21 times 10 to the 4 joules. Or 32.1 kilojoules if you want to do it that way as well. Okay, so does that agree with your answers there that you guys got? Yeah.